This time, instead of having equations for our functions, we will have table values. Let's try part A. Here we are to find g of f of 1. First, I will write this as g of f of 1 and set up my boxes. G of f of 1 means that 1 will go into the f box first, and whatever comes out will then go into the g box, and then whatever comes out is our answer. When 1 goes into the f box, we look at the table values for the f function. We see that the x value of 1 will yield the value of f of 1, which is 2. So 2 comes out of the f box and into the g box. Looking at the table values for the g function, we see that g of 2 yields 4. So my answer is 4. Let's try part B. Here we are to find f of g of 4, or f of g of 4. Setting up the boxes, we have 4 going into the g box, and whatever comes out goes into the f box, and whatever comes out of that is the answer. First, we need to find g of 4. Looking at the table values for the g function, we see that 4 is not in the domain of g, so we cannot get an output from the g box. Here we say that f of g of 4 is not defined because 4 is not in the domain of g. Let's go to part C. Here we need to find f of 3, written as f of 3. This means that we will put 3 into the f box, and whatever comes out will go into another f box, and whatever comes out of that is the answer. 3 into the f box from the table values for the f function, we see that f of 3 is 6. So 6 comes out of the first f box and into the second f box. Now we find f of 6, which is 7. So 7 is our answer. One note I want to make here is that the table values can be presented vertically, as in example number 3, or they can be presented horizontally. Here I will write the table values for the function f horizontally. For example number 4, we will use the given graph instead of table values to do the composition of functions. In our graph, let's first decide which graph is the f function and which is the g function. Let's let the line be the f function and the square root function to be the g function. For part A, we need to find f of g of negative 2. That means f of g of negative 2. Using our box notation, we need to put negative 2 into the g box, and whatever comes out goes into our f box, and whatever comes out of that is our answer. First, we will need to find g of negative 2. We know the x value for our point is negative 2, and it must be on the graph. From the g graph, we see that the point negative 2, negative 3 is on the graph. So g of negative 2 is equal to negative 3. Now we need to place the negative 3 into the f box. Looking at the f graph, we need to find the point that has the x value of negative 3. We find that the point negative 3, negative 1 is on the line, the graph of f. So f of g of negative 2 is equal to negative 1. Let's try part B. We need to find g of f of negative 5. This means we need to find f of negative 5 first. Looking at the linear graph, find the point on the line that has the x value of negative 5. It is the point negative 5, negative 3. So f of negative 5 is equal to negative 3. Now we need to find g of negative 3. Looking at the graph of g, we are looking for the point on the graph of g that has the x value of negative 3. From the graph's domain, we see that negative 3 is not part of the domain, so we cannot find g of negative 3. So we say that g of negative 3 is undefined, and therefore g of f of negative 5 is undefined. For part C, we need to find f of 0. Using the notation f of 0, we see that we need to find f of 0. Looking at the linear graph, we see that f of 0 is equal to 2, because the point 0, 2 is on the graph and has the x value of 0. Now we continue by finding f of 2. Again, using the same linear graph, we see the point 2, 4 is on the line and has the x value of 2. So f of 0 is equal to 4. Now try part D on your own. You may want to pause the video here to give yourself time to do it. The answer to part D is -1. And this concludes this video.